And welcome back, and it's the 11th of May, higher plus 5 a day, and let's just go straight to the first one. Okay, we have a triangle. So the first thing to note, and obviously this is what should go through your head when you're doing the exam, is we have a triangle. It's not a right angle triangle, so it's probably going to be cosine rule or sine rule. And the question says find the two possible values of theta, which is actually being quite generous because it's letting you know about the other value it could be. So sometimes it won't say that. So it is indeed the sine rule. So there's my opposite here. This 29 is opposite the 30. So actually this is not too bad a start, is it? So it's going to be sine theta over the opposite side, which is 40, is equal to sine of 30, which is a half. So actually, again, this has made it a little bit easier, over 29. Now, this wouldn't be a non-calculator question, simply because finding theta is too difficult. Anyway, calculator out. So theta equals sine minus 1 in one step, 40 times sine 30 over 29. So calculator out, and that tells me that's 43.6 degrees. Now, of course, where's the other angle come from? Well, the other angle comes from the idea that the sine curve looks like this, and there's one angle here, and this will give you the same angle or the same number as well. So in other words, I need the obtuse angle, which is going to be 180 minus the above, which is 136.4 degrees. And so again, if you add these two numbers up, you'll get 180 because of the way the sine curve works. And that is it. First question done. Not too bad. Second question, expresses a single fraction. So what I tend to start with is I'm starting with what my denominator is going to be, and that's going to be x minus 5 over x plus 5, which I know I can simplify, but I'll leave it like that for now because it makes it a bit easier to then multiply each of these things separately. So I need to multiply that by both x minus 5, x plus 5. I need to multiply the next one. Well, I've already got an x minus 5, so I need to multiply it by x plus 5, which can be x plus 5 squared. I wonder what this is going to simplify to. And the next one is an x plus 1, and I'm multiplying that by an x minus 5, which gives me everything over the same denominator. Now, I'm presuming it wants me to do a little bit of tidying up here, although it doesn't say it, it probably is implied. So let's try and do this in one go. I would say generally be a bit careful of this because it's easy to make an error. So x minus 5 times x plus 5 is x squared minus 25. That's going to be 4x squared minus 100. Then I've got x plus 5 squared, but I'm taking all that away. So that's minus x squared minus 10x minus 25. And then, no, be careful on this one. So I've got x plus 1, x minus 5, and I'm taking it away. So that's minus, well, it's going to be x squared. That's the easy bit. X times minus 5 is minus 5x. That's a plus 5x. 1 times x is plus x. That's a minus x. And 1 times minus 5 is minus 5. So that's a plus 5. And then I'm going to try and collect all this together. Now, in the exam, unless it tells you otherwise, it doesn't matter whether you do x squared minus 25 or x minus 5, x plus 5. They're viewed as equally simplified, if you like. Anyway, let's collect this together. So my final answer, actually, I'm going to do it in a different colour just so it's really clear. So my final answer is going to be, well, 4x squared minus x squared minus x squared is going to be 2x squared. Then I've got minus 10x plus 5x minus x. So that's minus 11x plus 5x, which is minus 6x. And then I've got minus 100 minus 25. That's minus 125 plus 5, which is minus 120, all over x squared minus 25. Now, what's interesting here is it doesn't actually say how it wants the answer. So if it doesn't say anything, that's fine. But you can actually simplify this slightly further, can't you? Because I can simplify this by taking a 2 out, which gives me x squared minus 3x minus 60. And then I can also, again, if it said factorize or simple form or gave some hint, maybe x minus 5, x plus 5. Again, I think either of these two things are okay, unless it says otherwise. Any of those red answers is probably fine. Use what it says in the question to guide you. Clearly, this is a sort of a textbook style question, but happy with all of that. Next question. Right, okay, this looks quite wordy. Kelvin bakes some brown bread loaves and some white bread loaves. He bakes 50% more brown bread loaves, slices 3/20, slices 1/8, sliced all of the loaves he has baked. Oh, sorry, he has sliced 28 of all the loaves he has baked. Okay, there's a few ways of doing this. So I'm going to start well, whichever way I do, it's going to be a bit messy. I'm going to start by saying my brown bread loaves are equal to X. And then it says he bakes 50% more. Oh, actually, I've made that already slightly tricky, haven't I? So therefore, my white loaves is going to be X over 1.5, because an increase of 50%, you multiply by 1.5. So that's back to front. Then what does he do? He slices 3/20 of the brown bread. So therefore, well, let's do slices here. So it slices 3x over 20, which is from here. And it slices 1/8 of the white bread, so this over here. Just an aside, so x over 1.5 is the same as x over 3 over 2, which is the same as 2x over 3. Just makes it slightly easier to do the next bit. So then I'm going to add on 2x over 3 times an eighth, which is going to be 2x over 24, which I can simplify down, but I'll leave that there for now. And I know that these together add up to give me 28. Okay, so basically what I've done is I've got to a nice equation, or a not very nice equation, I should say, and I now need to try and solve that. So let's now go into the solving mode. So next step, well, I'm just going to simplify it first. So I've got 3x over 20 plus x over 12 is equal to 28. Okay, and then I'm going to, well, what can I do? So I can do a common denominator of 60. So let's do a common denominator of 60. So multiply the first one by 3, which is going to be 9x. Multiply the second one by 5, which is going to be 5x. Good thing is I've now got it, everything in terms of x's at the top. And then divide all that by 60, and that's equal to 28. I have no idea if this is going to be a nice number. It must be, mustn't it? Because I must have a whole number of loaves. 9x plus 5x is going to give me 14x. Okay, good. Over 60 is equal to 28. Now, why did I say good? Do it in red so you can see the difference. So I can simplify this down to 2 and 1. And actually, you can see how this is going to work now. So therefore, my x is going to be 2 times 60, which is 120. Now, I will say, there's a lot of algebra going on there. So if you didn't quite follow bits of it, this is a really good example of just watch the video a couple of times or watch this bit a couple of times. Go back, check you're okay with each step I've done. None of the algebra there is too hard. And actually, moreover, it is algebra you should be okay with. Either way, I've got x equals 120. However, let's go back to the original question. What does the question say? Find out how many loaves Kelvin baked. Right. So now I need to go back to the amount of brown loaves was 120. The amount of white loaves was 120 over 1.5. Now you may want to have a calculator here, but I know the answer is going to be 80, because 80 times 1.5 is 120. So I add all these together, and the amount of loaves he bakes is 200. What a good question. I mean, that looked horrific with the words, and I have to say, I actually think it's probably worse than the wording suggests. So if you got that, well done. Right, talking of not very nice looking questions, calculate the surface area. Right, if you get a surface area question, start by working out what you have, just to be really clear. So I've got 1, 2, so I've got 2 sides there, or 2 faces. I've got the curvy face at the bottom, at the top, and the curvy face underneath, that's another 2. And then I've got the faces at the end, so that's another 2. So I am going to need 6 faces that I'm adding together. Right, so now I know what I'm looking for. Now I need to try and work them out. So let's start by, the upside of doing an iPad is I can delete these things. Let's start by doing the rectangles. Now, already, if the overall length is 20 and this is 12, 20 minus 12 is 8, and 8 divided by 2 is 4. So each of these things is 4. So therefore, the rectangles, I'm going to put the rectangles just so you know what I'm doing here. So the rectangles are going to be 2, because there's 2 of them. Times by 4 times by 50. 4 times 50 is 200, times by 2 is going to give me 400 centimetres. Okay, so far, I kind of think that might have been the easier part to start with. Then I need to, well, the upside again is I can delete all this now and see what I'm doing. Then I need to do the sort of curvy bits at the end. And again, there's 2 of those, isn't there? So I'm going to call them the curvy bits. So that's going to be, well, it's a circle minus a circle on the inside. So I need to go a stage further, don't I? So the radius of the big circle is going to be 10. And the radius of the little circle is going to be 6. There's a lot to this question, which means the curvy bits are going to be 2, because there's 2 of them, times a half, because they're semicircles, of pi times the big circle, which is 10 squared, minus pi times a little circle, which is 6 squared. Let's then tidy this up. So 2 times a half cancels out, which is going to give me 100 pi minus 36 pi. And 100 minus 36 is 64 pi. Wow, okay, we're getting somewhere, I think. Next bit, I need to do, which bit have I done? So I've done the outside. I'm going to leave the radii there because I'm going to need them in a second. I now need to do the sort of inside and outside bits. So we'll call these the inside and the outside bits. Again, in an exam, just as long as it's clear what you're working is, don't worry too much about the labelling. So I've got one of these, but I've got one on the inside, one on the outside. So the inside one is, well, the length, in other words, this bit here, is going to be half a circle. So it's going to be a half times the circumference of the circle, which is going to be 2 times pi times 6, times, because it's a if you imagine sort of stretching it out, it's a rectangle, times 50. And the one on the outside is going to be a half times 2 pi times by its radius, which is 10, and times that by 50 as well. So let's neaten all this up. Now, I haven't touched the calculator yet, but I suspect I'm going to need to do it in a minute. So a half times 2 cancels. 6 times 50 is 300, so that's 300 pi. And the outside one, again, half and 2 cancel. 10 times 50 is going to be 500 pi. So let's be clear about what I've got. I've got the rectangles. I've got the curvy bits on the ends, and then I've got the inside curvy bit and the outside curvy bit. If I add all of this together, I have got 300 pi plus 500 pi plus 64 pi, which is going to be 8. Actually, I can do it a different color, so again we can see what we're doing. So that's going to be 864 pi plus 400, and I'm happy with that as an answer. But just while I'm here, let's actually work out an approximation of that. So if I get my calculator out, that tells me 3,114,336,053, which I'm just going to call 3,110 centimeters. Yes, it is centimeters squared to 3 sig fig. And that is that not very nice, but actually pretty good question done. That's been 2 very hard questions in a row. I wonder what the next one is. The line y equals x plus 4 and the curve x squared plus 3x plus 4 intersect at the points A and B. So very roughly, I've got a parabola, and then I've got a line that goes up that looks like this, and this is A and this is B, although it doesn't matter which way around I do them. Find the distance between points A and B. So in other words, find the x values where these intercept, find the y values, then find the distance between the points. Let's do that. So I know that x plus 4 is equal to x squared plus 3x plus 4. Now they've made it nice and easy for us relatively, because if I take away 4 from both sides, I'll get x squared, take away x from both sides, plus 2x, the 4's cancel, which I can write as x plus 2, which means that I know the x values of A and B are going to be x equals 0 and x equals minus 2. And if x equals 0, then y, so I'm now using the x plus 4, so I'm using this here. So if x equals 0, then y equals 4, and if x equals minus 2, then y equals 2. So now, and it doesn't matter which one I call A and B, because it's the same distance either way around. So therefore I'm going to say A is equal to 0, 4, and I'm going to say B is equal to minus 2, 2, which means the distance, so A, B, and the little straight lines just mean distance. A bit more A level, we don't need to worry too much about that. So the distance is going to be, well, the distance between 0 and minus 2 is 2 squared, Pythagoras. Distance between 4 and 2 is 2 squared, Pythagoras. 2 squared plus 2 squared is 4 plus 4, so it's the square root of 8, which is 2 root 2, which is approximately 2.82427, etc. So I'm going to say approximately 2.83, and that is to 2 decimal places. You're going to hear the wow word again, aren't you? This is a really good set of questions today. In fact, actually, I think without exception, a great set of questions today. So well done if you got all those. Well done if you made your way for the algebra. Definitely well done if you got that surface area question. Very easy to mess that one up. Let me know how it went for you. Like, subscribe. See you tomorrow.